Alright guys, this is to help you with problem number 2 on your sheet. First of all, you can see I've already got my statement and reason columns because you know that I'm going to need them. Okay, our next step is always to look at what we've been given. Our first given is that CD is perpendicular, which is this symbol here, to AB. So what that actually means perpendicular is that it makes it right angle. Okay, the right angle can go on both sides of that because we know straight lines have to be 180 degrees, so both of them have to be 90. All right, now the next piece of given information is that D is the midpoint of AB. Okay, so if it's the midpoint, that means it's right in the middle, which means both sides have to be congruent. Now this diagram's kind of tricky because they don't look like they're the same size. Okay, but in geometry, none of our diagrams are ever to scale. So you can mark those on as being congruent, even though they don't look congruent. Now I've got 2 bits of information that I definitely know are true. So I need one more in order to prove congruence. So what I'm going to do is go through my little thought process. I want to look and see if there's any vertical angles I can use, because they're really easy to spot. Now in this case there's no vertical angles, but what I do see is that both triangles rest against each other at this line CD. Okay, so it's going to be my third piece of information I'm going to use to prove my triangles. Okay, all of our proofs involve you proving a set of triangles are congruent. So because our information was in both of those, I need to prove them both. Now this is where we get to our statement reason section. I need to state our givens first because we're definitely going to use them. CD is perpendicular to AB. It was given. Now, it didn't tell us anything about the right angles. Okay, so I need to point out how I knew that. So I can now say that angle CDE is congruent to angle CDB. And the reason for that is that perpendicular lines create congruent right angles. All right, now usually we say just put both your givens first, but I just wanted to put that one next to each other so that you know, okay, what's going on there. That was our first thing we did. The second thing we did, okay, I'm going to number it 1 and 2, was that we looked at D being the midpoint of AB. Okay, so I'm going to put that in as a given because we used it. Okay, we were given that. But we got information from it, and that's our next statement. Okay, the information we got from it was that AD is congruent to BD. All right, that information we got because we knew the definition of a midpoint. All right, our third and final piece of information to prove congruence. Our third thing was that CD was congruent to CD. So you can see we've got lots of points and lots of reasons in this particular proof. Okay, so, you know, it'd be worth a lot of points if you were to actually have to set this one up. I'm going to say that's a shared side. You could also say it's reflexive. Now I have enough to prove our 2 triangles are congruent. So I'm going to say that. Triangle ADC, I'm going to call it. Now remember, when you talk about triangles, the order is important. So we're going to call this triangle BDC so that our order matches up. Right, and that's via side, angle, side. But we still haven't actually proven what we set out to, which is that CA is congruent to CB. All right, I'm just going to colour those guys in orange. Okay, that's the hypotenuse of our triangle. We didn't have it, which is why we couldn't use HL when we proved our triangles were congruent there in step 4. So our final statement is that CA is congruent to CB. And our reason behind that is our new one, cpctc, or corresponding parts of congruent triangles are congruent.